So we're going to be talking about the introduction to proofs today. So you've probably dealt with proofs before in math. We're just going to try to do this with an UNO proof. So you've probably played UNO before. So these are the cards that we're going to deal with. We have a green 5, a green 3, a blue 3, and a blue 4. And we want to show that we can get from a green 5 to a blue 4. So we're given these cards. That's what we're just going to start with. And we're going to prove that we can get from the green 4 or green 5 to the blue 4. So the way we normally do this is we make a chart. One of the columns is going to say statements and the other one's going to have justifications. So in each column we're going to make something. So for example, statement 1 can say green 5. I'm just going to start with a green 5 because that's what I'm given. Step number 2 is I can play a green 3 because it's the same color. Those are the rules. I can only justify according to the rules that I'm given. Step number 3 is I'm going to play the blue 3 because it's the same number. And step number 4 is I'm going to play the blue 4 because it's the same color. So I have managed to get from a green 5 to a blue 4 using the previously agreed upon rules. And in proofs in math, you have to use certain rules also. So there's 4 rules we're going to talk about. The first rule is the given statements. So in the earlier example, we talked about how we were given these cards. So we are given that to start with. Anything from the problem we're allowed to use. Step number 2 is definitions. So for example, a linear pair definition is a ray coming off of a line that creates 2 angles that are linear pairs. That's the definition of a linear pair. Postulates include things that are just given. We know them for sure. Like a point is something in space, or a line is a segment that connects 2 points. Just things like that. Euclid says something else about a circle, but we are also allowed to use things like translation, reflection, and rotation. So these are also allowed to be postulates. There's a couple of others we're going to talk about later, but like angle addition postulate, but those are important to remember. The 4th thing we can use is previously proven proofs or theorems. So this includes like the vertical angles are congruent. Linear pairs are supplementary. That is a different theorem that we are allowed to use now that we already have proven it and used it. So all of these things we're allowed to use in our proofs. So we're just going to do a quick example to show how they work. So we're going to scroll over here. I'm going to make a little diagram. So these are just 2 parallel lines cut by a transversal. So I have lines L, M, and T. So given this diagram, given that L is parallel to M and T is a transversal, I want to prove that angle 3 is congruent to angle 6. So I'm just going to label the 3 and the 6 over here. So this is basically to show that alternate interior angles are true. So I'm going to make my little chart, statements and justifications. So the first thing I'm going to write is that L is parallel to M. And this is just given. This is from the original problem. The second thing I can do is translate M to L. So I'm just going to make some more angles here so that I can talk about them later. But I'm allowed to translate M to L because of the translation postulate. So the third thing I'm going to do is now I know that since I've translated, that angle 6 maps to angle 2 because of the properties of a translation. And properties of a translation are included both under the postulates and under previously proven theorems. It's whenever we translate, and if we translate it, those things are going to match up. So translation properties. I'm going to use that justification again. Now, because 6 maps to 2, angle 6 is congruent to angle 2. So it's just the same reason as before. Statement number 5 is I know that angle 3 is congruent to angle 2 because they're vertical angles. Though that's a previously proven thing that we have talked about. And so statement number 6 is that angle 6 is congruent to angle 3, or angle 3 is congruent to angle 6 because of the transitive property. So because I know 6 is congruent to 2 and 2 is congruent to 3, that means 6 is congruent to 3. So that's my proof. And we're going to be practicing a lot more, but hopefully that helps to introduce you, and we'll have a list of different things that you can use to help you to practice.